Picture our sun, a blazing titan that powers life on Earth, its golden light stretching across the solar system, a force so immense it seems untouchable. Now, imagine something so cataclysmic, so powerful, that it makes our sun look like a flickering candle in a cosmic storm. Beyond our cozy corner of the galaxy, in a distant cloud of gas and dust, a star met its end in a spectacle that shook the heavens. This wasn't just any star, it was a blue supergiant, and when it exploded in a supernova, it lit up the night sky with a brilliance that captivated humanity. That event, known as Supernova 1987A, wasn't just a cosmic fireworks show. It revealed secrets about the universe that scientists are still unraveling, and it holds clues to a mystery that could reshape how we see our place in the cosmos. Join us as we journey to the Large Magellanic Cloud, peering through the lenses of the world's greatest telescopes to explore this stellar explosion and what it means for the future of our universe. Let's set the stage. It's February 23, 1987, and astronomers around the world are buzzing with excitement. In the southern skies, a new star appears, so bright it's visible to the naked eye. But this isn't a star being born, it's a star dying, in the most spectacular way possible. Supernova 1987A erupted in the Large Magellanic Cloud, a dwarf galaxy 168,000 light-years from Earth. To put that in perspective, the light we saw in 1987 left that star when our ancestors were still painting caves. If you could travel at the speed of light, it would take you 168,000 years to reach the site of this explosion. Even with our fastest spacecraft, the journey would take billions of years, long after human history fades into dust. This distance is staggering, yet the supernova's light reached us with such intensity that it became one of the most studied events in astronomical history. What makes Supernova 1987A so special? For starters, it was the closest supernova observed since the invention of the telescope. Before 1987, the last naked-eye supernova was seen in 1604, when Johannes Kepler marveled at a new star in the sky. Supernova 1987A gave scientists a front-row seat to a cosmic catastrophe, and they weren't about to miss it. The star that exploded, called Sangelique-69202, was a blue supergiant, roughly 20 times the mass of our sun. Unlike our sun, which will one day fade into a gentle white dwarf, this star was destined for a violent end. As it burned through its fuel, its core collapsed under its own gravity, triggering an explosion so powerful it outshone entire galaxies for a brief moment. That blast released as much energy in a few seconds as our sun will produce in its entire 10 billion-year lifetime. But the story doesn't end with the explosion. When Supernova 1987A lit up the sky, it didn't just dazzle astronomers. It gave them a treasure trove of data. Telescopes across the globe, from the hills of Chile to the peaks of Hawaii, turned their gaze to the Large Magellanic Cloud. Even more incredible, neutrino detectors, underground tanks designed to catch ghostly particles, recorded a burst of neutrinos from the supernova. These tiny, nearly massless particles traveled 168,000 light-years, passing through stars, planets, and even you, to reach Earth just hours before the light arrived. This was a game-changer. Neutrinos are like cosmic messengers, carrying secrets from the heart of the explosion. Their detection confirmed theories about how stars die, earning scientists a glimpse into the universe's most extreme physics. Now, let's paint a picture of what this supernova looked like. Imagine a star 100,000 times brighter than our sun, its surface a searing blue, pulsing with energy. As its core collapsed, it unleashed a shockwave that tore through the star's outer layers, hurling gas and dust into space at speeds of 70 million miles per hour. The explosion created a glowing remnant, a tangled web of gas filaments and shockwaves that astronomers still study today. If you could stand on a planet near the Large Magellanic Cloud, the supernova would have been brighter than 1,000 full moons, casting eerie shadows and painting the sky with hues of violet and white. Here on Earth, it appeared as a pinpoint of light in the constellation Dorado, but its impact was anything but small. One of the most exciting discoveries came years after the explosion. Astronomers noticed rings of gas around the supernova's remnant, illuminated by the blast's intense radiation. These rings weren't formed by the explosion itself, but were material ejected by the star thousands of years earlier, lit up like cosmic neon signs when the supernova's light hit them. The brightest ring, about a light year across, looks like a glowing hoop in space, with knots of gas that sparkle like diamonds. These rings are a snapshot of the star's life before it died, telling us it was a restless giant, shedding its outer layers in powerful stellar winds. The Hubble Space Telescope captured stunning images of these rings, revealing details so sharp you can almost feel the texture of the gas. Each knot, each twist, is a clue to the star's final days. But supernova 1987A isn't just a pretty picture, it's a cosmic laboratory. Scientists have used it to test theories about how elements are born. You see, the iron in your blood, the calcium in your bones, even the gold in your jewelry, were forged in the hearts of stars like this one. When a massive star goes supernova, it acts like a cosmic furnace, fusing lighter elements into heavier ones in a matter of seconds. The explosion then scatters these elements across space, seeding future stars and planets. Every atom in your body was once part of a star that died in a supernova, maybe even one like 1987A. It's a humbling thought. You are, quite literally, made of stardust. The supernova also raised a tantalizing question. What happens to the star's core after the explosion? In most supernovas, the core collapses into a neutron star, a dense ball of matter so compact that a teaspoon of it would weigh as much as Mount Everest. In some cases, the core becomes a black hole, a region of space where gravity is so strong not even light can escape. For supernova 1987A, the answer is still a mystery. Astronomers expected to find a neutron star at the center of the remnant, pulsing with radio waves or X-rays. But despite decades of searching with telescopes like Chandra and ALMA, no neutron star has been found. Some think it's hidden behind clouds of dust, its light blocked from view. Others wonder if the core collapsed into a black hole, silently swallowing any evidence. This unanswered question keeps astronomers awake at night, and it's one of the reasons supernova 1987A remains a hot topic. Let's talk about the remnant itself. Today, the site of supernova 1987A is a chaotic dance of gas and shock waves. The explosion's blast wave is still expanding, slamming into surrounding material and creating glowing hotspots. The Atacama Large Millimeter/Submillimeter Array, or ALMA, has mapped this remnant in exquisite detail, showing clumps of dust and gas that could one day form new stars. These observations reveal a universe in constant motion, where destruction leads to creation. The dust grains in the remnant are like cosmic seeds, carrying the building blocks of future worlds. In a billion years, planets might orbit stars born from this very explosion, perhaps even hosting life that gazes up at their own night sky. Now, let's zoom out and think about what supernova 1987A means for us. While it's too far away to affect Earth directly, its study has deepened our understanding of the universe's life cycle. Stars are born, live, and die, just like us, but their deaths shape the cosmos. Supernova 1987A showed us how neutrinos travel, how elements are forged, and how shockwaves sculpt the interstellar medium. It also reminded us how rare and precious these events are. The next naked-eye supernova in our galaxy could happen tomorrow or 1,000 years from now. If it's close enough, it could outshine the moon, turning night into day for weeks. Imagine stepping outside to see a new star blazing in the sky, knowing it's the final cry of a star that lived for millions of years. Wouldn't that be a sight to behold? There's another star worth mentioning, one that shares the stage with supernova 1987A. In the constellation Orion, Betelgeuse, a red supergiant, is nearing the end of its life. Like the star that became supernova 1987A, Betelgeuse is massive and unstable, its surface pulsing as it burns through its final fuel. Some think it could go supernova in our lifetime, though lifetime, in cosmic terms, could mean centuries. If Betelgeuse explodes, it'll be brighter than anything we've seen since 1987, a cosmic beacon visible even in daylight. Comparing the two stars is like looking at a before and after picture. Betelgeuse is the before, a star on the brink, while supernova 1987A is the after, a star that crossed the threshold. So, here's the big question. What if supernova 1987's core did become a black hole? If it's there, hiding in the remnant, it could be warping space and time, a silent monument to the star's death. And what if another supernova, closer to home, lights up our skies? Could it change how we see the universe, or even inspire new questions about our existence? Do you believe we'll find that missing neutron star, or is a black hole the answer? And would you want to witness a supernova in your lifetime? Your thoughts keep this cosmic conversation alive.